welcome back. Today we're doing Leetcode problem 199, binary tree right side view. So given the root of a binary tree, imagine yourself standing on the right side of it. Return the values of the nodes you can see ordered from top to bottom. Pretty straightforward. So if you look at the picture here, given this tree, you're just going to return 1, 3, and 4. So imagine you're standing like right here and you're looking at the tree from the right side. What nodes can you see? It's a pretty cool problem. I like it. And the second example, like 1 null and 3, I think it's a better, the image is pretty important for understanding this problem. So if we take a look at this drawing here, basically the idea is like if I'm some guy standing right here and I'm super tall, I have a really long torso, I also have really big biceps. All right, so what can I see level by level, right? And that's a kind of a hint already. I can see this guy, which is a 1 at the top level, and then I can see this guy, which is a 3. But if I shrank myself, really, like, I can still see this 4. But the point of this drawing here is that we're not always just going to be taking the right side of the tree. Technically, I can see over here too, right? Because although this is on the left side of the tree, because there are no nodes on the same level on the right side, I can still see the 4. So in this case, we would want to grab the 4 as well. And we want to return some result, like a list that has these numbers. And so earlier I said the words, we want to go level by level, and I think that's the approach that we're going to take. Is we're going to do a BFS on the tree and go with the level order traversal. So each of these arrows points to the level that we're going to process. So it's going to be a BFS, and we're going to go with like a level order traversal. So the first one, we would be processing this guy. And since this level only has 1 item, that's how we know that we can just throw on the 1. But usually for like a level order traversal, you want to get everything in the level. So with this level, you would take the 2 and the 3. We don't need to do that. We can just keep up like a rightmost element. And when we're at the end, or really as we're processing these, we'll just replace what that is. So the rightmost will be a 2 first, and then we'll handle the 3, we'll process it, and we'll just replace it with the 3. So that way you'll get to the end, and then you will have your rightmost element, and you can just throw it onto that list. Same thing with this level here, with this 4. But since there's only one thing, we're only going to process 1 element and then throw it onto the end of the list. So let's just code it up, and I think it'll make more sense while we do it. I'm gonna drag this over. So let's just check our input first. If it's none, I can just return none. I think that's always a good idea to do. And let's create our result, some empty list. And we're gonna, like I said, level order traversal. So what does that mean? We're gonna do a BFS and take rightmost element on that level, and we'll just throw it into our result, right? And to do a BFS, well, we use a queue. So the first thing I'm going to do is just throw that root on there. And so while there are still items to process in our queue, I'm going to take the size of the queue because that tells me how many elements to process at that level. And I'm also going to do rightmost, and that's going to be the element that we keep updating so that at the very end of that current level we're on, it will represent the rightmost element that we can see. In range of our size, we're now looping through the level. We have to popping from the front, and we'll check if it has children. If there's a left pointer, we'll throw on the left pointer. If there's a right pointer, we'll throw on the right pointer. Okay, at this point, what we can do is assign our rightmost equals the node.value, because that's the current node that we're on. And then when we exit this loop, we are done traversing that level. So we can just append to our result. And I think that's it. We just return our result, right? Let's take a look. Great. Submit this guy. Nice. So again, looking not at the solutions, let's look at how the problem is written. This loop here on 22, when this finishes, that means that we're done processing the current level that we're at. And again, sometimes people get tripped up on why we're using this size and what it represents. That size is going to represent how many nodes are at the level that we have to explore. So first it's going to be a size 1 for the root node. Then the size becomes 2 because we compute it again. There's 2 nodes at the second level and then 2 nodes at the third level. So yeah, that's pretty much it. I think the runtime for this is BFS, so it's going to be O of m plus n, which is like the number of nodes and edges that you have to explore. We're kind of going through the whole tree level by level. So in space-wise, well, it's O of, yeah, I think it's O of n as well, because in the worst case, we're using this result list, and in the worst case, well, it's just a tree with right side values, right? So everything in the tree would then be in our result. But yeah, I hope that helps.